Today we're going to do some more with lists, and we're going to try and do some math with lists, with numbers, and just see a couple examples. And the first example we're going to look at is one called grades. So what I'm going to do in here is put a number of maybe test grades or program grades, who knows. So they got a 93, then they got 85, 90, oh, not too good on the last one, they only got a 75. So I've created a list, and as we said before, to create a list, you put them in brackets. Now I'm going to create an accumulator. Let's call that accumulator. And what I did was I initialized in this line. So I said the sum of all those grades has to start out with 0. Maybe it's a new quarter, or so we're don't have any other grades to add. Now here's where it's really nice, where Python makes it very easy to read. So we're going to say for each score in the list grades. We could have gotten the length of the list and done all that, but this is easier because we just give it a name and the variable will be our counter. So maybe we're going to print what the score is. One score is comma score. Remember, we have to have a comma to link things. And then sum will be equal to sum plus score. Now I'm getting a purple thing there for sum, so I'm hoping that's not going to give me troubles. I'm hoping that's going to be okay. If it isn't, we'll have to make it sum 1. They may have changed something in this version of Python, but let's run it and see. If we have a mistake, it's not the end of the world. So the average will equal the sum divided by the length of grades. And I need 2 parentheses there. Now, I'm not trying to pull a fast one here. What I'm doing is, just like I would average your test scores. If you had 5 test scores, I'd add them up and divide by 5. Well, this list could change. And I'm going to show you that in a minute. So it's better to do it this way, to say divide by the length of the grades. And then, of course, we'll print the average. Print the average is comma average. And like I said, we're going to see if that sum gives me any troubles in about 2 seconds. Here's the moment of truth. No, it was okay. It was all right. So it printed out our scores, and it averaged them out. Now let me show you why it's nice to use score and to use length of grades. Let's say for this particular semester, I decided to give an extra test. Maybe I wanted to give people a chance to make up some points. So I said, we're going to have an extra test. We'll have an extra grade for that quarter to help you out. And the student did pretty well, got a 91. I don't have to change anything in the rest of the program. Nothing. Because it says for score and grades. It doesn't say how long. It just says, hey, go through each score. And when I divide, it says, well, just do the length of grades. Now let's run this, and the student's grade should have gone up a little bit, maybe up to a 90 or so. We'll see. 89. Okay, went up a point. Now let's say you have a teacher who's really, really kind, and they say, I'm going to drop a test. Sometimes that happens in college. They'll give you 4 tests or 5 tests, but they drop the lowest, or they'll drop a quiz. Some teachers are pretty nice like that. So this teacher said, no problem, I'm going to drop that 75. I don't have to change anything. We don't have to adjust anything in this program. We just run it, and it still works, because we didn't specify how many. Now we're going to do one more program for today, and we're going to do one with elements. So, oops, let me delete all that. Print the elements program. I'm just giving it a simple name because I don't want to spend a lot of time on that. So we're going to put in the elements from 1 to 10. And if you've had a chemistry or a science class, you had to hit this somewhere along the line. Lithium. So you see that I'm building a list, and I want these all to be words. Beryllium, carbon. You can see how fast or slow I am of a typer. We'll make this a capital C just to be exact. We're almost there. Oxygen. And you can tell that I'm originally trained as a chemist because I have all these memorized. And oops, neon there. So you didn't know you were going to learn a little chemistry today. Let's make sure I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which one am I missing here? Boron. That's the one I'm missing. Okay, so no problem so far. Now what I'm going to do is I'm going to ask you, I'm going to say x equals integer input, enter an atomic number from 1 to 10. Because we're not going to do the whole periodic table. We could if we had a little more time, but we're not going to do that for this example. That's crazy. Now the problem is, let's say I enter a 10. Element 10 is neon. But what would be its numbering value, its index value be in this list? This goes 0, 1, 2, 3. It would be 9. So if I enter a 10, I have to say position equals x minus 1. Or excuse me, plus 1. Oh, no, we're right, minus 1. Because I'm going to enter a 10, but we need to be at position 9. And then we can say print the elements symbol is. Now we're going to access that position. So we're going to say names, which was what I called the list, and that particular position. Let me give you a second just to look at this, and we'll just quickly say what we did. We made a list. We asked which one of those list values do you want to take a look at. We got the position is x minus 1. We're going to print it. And let's see if it runs. Yeah, I want to save it. That's good. So if I enter 10, I should get neon. And let's run it again. If I enter 3, I should get lithium. Now the only thing I would change is, you notice this doesn't look too nice here. Probably when I asked for this number, I should have put a space in there. It's a small thing, but it makes it look much better. Let me just prove that to you. So element 6 should be carbon. And yeah, and element 8 is oxygen, just double checking. Everything works great here. So we make our list, and then we can access any of the positions, any of the elements of that list that we want.